if we're using unit analysis, we're just stringing basically the same thing that we've done into a longer set. So we're doing it all as one multiplication, not doing the cross multiplying. So I would start with my original unit over 1. I'm going to multiply that by the ratio of what I'm converting to, making sure that if my original unit is on the top, in this case kilometers, it needs to be in the bottom of the next set in order to cancel out. Then do the same thing again. Now I would have canceled out kilometers, and now I'm in meters. If I want to go from meters to millimeters, I'm going to put meters on the bottom, cancel this out, and then just be left with millimeters. If, when I'm doing my ratio, the number's on the bottom, that would be the same as divide. If it's on the top, that would be the same as multiply. So we can see that the numbers here are all on the top, so it's the same as multiplying by all these, because they would all be over 1. So if we're going to take the same process that we did in example 3 and use proportional reasoning to do this, what conversions will a student need to do in order to solve this problem? Well, I'm going to convert from miles to feet, and then convert from feet to inches. So I start out with my original unit, 0.05 miles over just 1. I'm going to multiply that by, there is 5,280 feet over 1 mile. And then I'm going to go from these feet to, there's 12 inches in every foot. Miles cancels out miles, feet cancels out feet, and then I'm just left in inches. And I get 3,168 inches. All of these were just single units, but what if I started out with a ratio? A physics student was required to convert an answer of 75 meters per second into kilometers per minute. Well, now I'm going to need to convert my meters to kilometers on the top, and I'm going to have to convert my seconds to minutes on the bottom. So what I actually have to start is I have 75 meters for every 1 second. Now I'm going to convert those meters to kilometers by saying that I have 1 kilometer over 1,000 meters. And my meters will cancel out, and now I'm just left in kilometers with seconds on the bottom. And then I'm going to multiply that by 60 seconds over 1 minute. The seconds started out in the bottom, so I need to put it in the top to cancel those ones out. And now I'm just left with my kilometers and my minutes, which is what I'm looking for. So this would be the same as 75 divided by 1,000, which is the same as multiplied by 1 over 1,000, and then multiplied by 60. And I'm going to get 4.5 kilometers per minute. If we're taking a quick look at slope again, I know we did this earlier on this unit, or in this course, but if I'm considering the line segments A, B, and C, D, use the slope, or determine the slope using the rise over run method. Well, to get from point A to point B, I had to go up by 3, and I had to go right by 1, 2, 3, 4, 5, and 6. Which means that the slope is going to be 3 over 6 or 1 over 2. So my slope of AB is equal to 1 over 2. For CD, I had to go down by 3 and right by 4. So my slope of this is going to be negative 3 over 4. If I'm using my slope formula in order to determine this, I need to figure out what these points are. Well, I can see that point A is going to be 1 and 8. Point B in this case is 7 and 11. So my slope of AB is going to equal, I got to stack them on top of each other, the y value for point B minus the y value for point A divided by the x value for point B minus the x value for point A. And I get the same answer I had before. For point C, C exists at the point of 6 and 5, and D is at the point of 10 and 2. So my slope of CD would be 2 minus 5 over 10 minus 6. This is going to give me negative 3 over 4, which matches the information that we already had. Does it matter if we only use the endpoints or if we pick any other point found along the line? Well, I can see right away for AB, I could take this point and then just pick another point that's in there, and here I went up by 1 and right by 2. The slope there is still going to equal 1 over 2. So, no. Any 2 points will work. For the statements, slope is the measure of the steepness of a line. Slope is the ratio of the vertical change, called the rise, over the horizontal change, which we call the run. A line segment which rises from left to right has a positive slope. If it falls from left to right, it has a negative slope. A horizontal line segment has a slope of 0, and a vertical one has a slope of undefined. The slopes of all line segments on our line are always going to be equal. Don't worry about the accuracy and enrichment precision.